The Berkeley Education Alliance for Research in Singapore, or BEAR Center, is a University of California Center for Research, Graduate Education, and Innovation with the goal of achieving an international reputation. BEAR serves as an intellectual hub for interactions between University of California Berkeley researchers and their counterparts, from universities to polytechnics, research institutes, and industry in Singapore. In this video, we will be presenting three topics: the SMEPS2 program, CITRIS, and CITRIS Foundry.
Thank you for the opportunity to present to you here today. My name is Kostas Panos. I'm a professor of electrical engineering and computer sciences at UC Berkeley, director of BEARS, and lead investigator of the Singapore Berkeley Building Energy Efficiency and Sustainability in the Tropics. SBB, as we call it, or SBB2, is a major program under BEARS now in its second 5-year run. Our objective is to advance technologies in buildings for design and operation for maximum efficiency and sustainability in tropical climates specifically. And more specifically, we have two objectives. One is to reduce energy consumption by a factor of 2 based on a metric based on 2015 standards, and increase the fraction of occupants that report satisfaction with the respective built environment by 30%. Of course, we also aim to facilitate transferring these innovations to the marketplace. Today I will focus on 3 key items: the CyberPhysical Test Bed in the Create Tower, our innovative mixed mode ventilation that produces significant energy and greenhouse gas emission savings and enhanced thermal comfort, and our living test bed in collaboration with the Building and Construction Authority. The CyberPhysical Test Bed that exists on the 11th floor of the Create Tower is a truly unique multifunction facility. It allows us to do experiments with human subjects on thermal comfort and the quality of the indoor environment, daylighting experiments, nanogrid experiments for energy transfer, and many other things. And I will show you a brief video that highlights some of the aspects of this unique facility. 100 square meters of chambers. Will be quick highlight on 4 items: lighting, ACMV, data management, and nanogrid. The ACMV system has many configurable air handling units. And when I say configurable, you can do lots of experiments, almost everything under direct computer control, direct controlling the environment into these 4 chambers that can be used with human subject experiments. The lighting system produces true daylight under our control with various colors to simulate various parts of the day. We can do glare experiments, we can do harnessing daylighting experiments. We have an artificial sky, as you can see here, that we can use fenestration work with building models. Very realistic. The nanogrid system allows us to do lots of experiments both in simulation and emulation about managing building loads very quickly and dealing with buildings, how they interconnect with the grid and with other buildings in what we call transactive energy. That involves many technologies both within the building and beyond in order to manage demand response. The data management system is a very comprehensive database that collects everything that happens in the test bed through hundreds or even thousands of sensors that we have throughout the system, including sensors that we can put in the community in this building, the briefcase demonstration that you see here. And of course, we use these facilities, we use the system to monitor everything and to do data analytics and what if scenario. The mixed mode ventilation system is something that we're very proud of. Is a combination of air conditioning and ceiling fans. What you see here in an accelerated video, the airflow is actually smoother than this. But we did this because we know that we can compensate in thermal comfort if we increase the temperature of the air conditioning by a few degrees and save quite a bit of energy. We can compensate for this thermal discomfort by having some slight, even imperceptible air movement. This is a technology that has been tested thoroughly in the test bed. It has been tested in simulation, it has been tested in human subjects, and it allows us to run up to 3 degrees hotter than normal by compensating with ventilation, with air movement. I'd now like to show you a very brief video that shows some of the characteristics of the BCA ZEB Plus living laboratory. It has a system for test bed building manager service, interlocalization, elevated airspeed, and user personal settings. The test bed building management serving system is essentially comprehensive software that connects all the systems of the building and provides unique visualization of all the data collected and control capabilities. It is connected to hundreds of sensors throughout the space, and it allows the occupants to configure the personal space to their satisfaction. The building is responsive to not only occupancy density but occupant location, and it is quite individualized. In this example, this occupant of the building will move to a different space, and you can see how the space reacts. You can see the fan going on and the lights turn on. What you don't see is that the settings are customized to the preferences of this individual, and the building knows who he is and where he's at. Here you see the actual space in action. You can see the actual speed of the fans, and you can see that we have shown that we can go into the comfort zone by elevated temperature. This is the user personal space setting system that shows how configurable each space is, and it is meant for the users to configure their special preferences, so they follow them around from the desk to the common spaces and so on. I'd like to thank you for your attention and appreciate your support.
How do you take an idea and develop tools to change people's lives? It all starts at the center of public education, the University of California. Combining the strengths of 4 UCs with world-class research facilities and the brightest minds in industry, it's a perfect formula for innovation. We're creators, designers, educators, and policymakers who never sit still and always look to the future. Changing the world is an ambitious mission. We're opening the doors wide to everybody who wants to join us. We are the Center of Robotics and AI. Let us introduce you to new partners and collaborators who will work alongside you, not against you. We are the Center of Health Tech. In the near future, a doctor's visit could be just as easy as using your smartphone. We are the Center of Technology Policy. We're evolving alongside technology and advancing frameworks to help people start the tough conversations. We are the Center of Sustainable Infrastructures. We want to leave behind a better world, so we're building systems and structures that will protect rather than pollute. So, how do you take an idea and develop tools to change people's lives? It all starts here, at the Center for Information Technology Research in the interest of society. Citrus and the Banatao Institute.
The last 2 to 3 years, we've really seen a growth of life science and health startups that are coming through the Citrus Foundry. There's a growing number of these health and biotech companies that are both applying to our program and participating in our program. Now, maybe about 40 to 50% of companies we work with now fall within that space.
If you go to a primary care doctor, first, they will not really send out too many DNA tests. And if they send it out, they send it to these centralized labs. We're basically trying to bring that centralized lab testing into the doctor's office. So you get your results of multiple diseases right there on site and right away in 15 minutes. And you get the same kind of sensitivity while paying 10 to 100 times lower cost for the patient.
These days, the cost of starting a biotech or a health startup has actually dramatically reduced. The tools there are much more readily available.
Right now, if a patient comes in with one of these higher kind of risk urinary tract infections, they give the sample to the doctor or the medical personnel, and then they take that sample, and then it takes them 2 to 3 days to work it up and know exactly how that patient should be treated. So we would really change the workflow by enabling doctors to treat that patient immediately.
Just completed a large-scale urinary tract infection study at Highland Hospital where we validated the core technology on real patient samples. So we tested nearly 500 urine samples from patients with suspected urinary tract infections, and we had some really good results from that study.
Researchers are not just interested in doing their research, publishing papers, but finding a way so that they can bring this out to the world through application.